Okay, so mhm. கிளாஸ் இப்போ என்னோட ஆடியோ வந்து எதுல இருந்து உங்களுக்கு வந்துட்டு இருக்கோ அதே இதுல வந்து இப்போ வீடியோவும் வரும். கிளியரா தெரியுதா? ஆடியோ அண்ட் வீடியோ ரெண்டுமே ஒரே டிவைஸ்ல இருந்தாப்பா உங்களுக்கு இப்போ வந்துகிட்டு இருக்கும். இஸ் தட் கிளியர்?
Yes, sir.
Yes, sir.
ஓகே. இப்போ இப்போ மீட்டுக்குள்ள இருக்கிறவங்கள வந்து யாராவது ஒருத்தங்க வந்து லேப்டாப்ல இருந்து லாகின் பண்ணியிருக்கீங்களா? எனிவன்?
சார் நான் பண்ணியிருக்கேன்.
ஓகே.
நான் பண்ணிருக்கேன் சார்.
சரி. ஓகே, லேப்டாப்ல லாகின் பண்ணியிருந்தீங்க அப்படின்னா நீங்க சைட்ல வந்து அந்த யூடியூப் பேஜை ஓபன் பண்ணி வச்சுக்கோங்க. அந்த லிங்கையும் ஓபன் பண்ணி வச்சுக்கோங்க. ஸோ இங்க என்னது வந்து சைமல்டேனியஸா 2 கேமரா வந்து ஆன் ஆகல லேப்டாப்ல. தட் இஸ் வை ஐ எம் நாட் ஏபிள் டு மானிட்டர் தெம். ஸோ யூ பீப்புள் மானிட்டர். அட் லாஸ்ட் முடிச்சதுக்கு அப்புறம் வந்து ஐ வில் செக் வெதர் ஹவு தே ஆர் ரைட், எந்த அளவுக்கு அவங்க அட்டென்டிவா இருந்தாங்க அப்படிங்கறது வந்து ஐ கேன் செக். ஸோ ஃபைன். So the first question that we are going to see is we are asked to find out the value of the integral of some function g of z around the circle absolute of z minus iota equals to in the positive sense. When your function g of z
Sir.
is given to be f,
சார் த வேல்யூல இருந்து தான் சார் தெரியுது, அதுக்கு முன்னாடி இருக்கிறதெல்லாம் தெரியல.
போனை flip பண்ணி வைங்க.
ஓகேங்க சார்.
And when your g of z is 1 upon z square plus 4 whole square. So உங்களை என்ன கண்டுபிடிக்க சொல்லியிருக்காங்க? What is the thing we are asked to find out?
Value of integral around the circle, sir.
So value of the integral around the circle. So which integral?
G of z.
Okay, g of z dz
of z.
around a contour c. What is the contour here?
Circle, sir.
Which circle?
sir.
Which circle? Circle is the right answer. Which circle? Sorry?
Sir, absolute of z minus I.
Absolute of z minus I.
Equals to. This is the circle that is given to us. Okay, guys, only these 11 people can stay in the meet. Others kindly join in YouTube. So this is the circle. So if we draw this circle, like I'll use the space. Which is my center and how is my circle look like?
Sir, center is at I, sir. Iota.
Iota. So here.
With radius 2.
With radius 2. So we would get a circle of this form. Am I right? Stick. Somewhat like this. Am I right? Plus, am I right?
Yes, sir.
Okay. Okay, now. So with which, what should we do? The first thing is we'll have to integrate this one over this. What are the singular points for this? Or is it necessary for us to find out the singular points in order to evaluate this integral? Guys, is my question clear? What should we do to evaluate this integral?
Sir, we
Guys?
can write 4 square.
Yeah. Tell me.
Sir,
We can write.
z square plus 2 the whole square. Z square plus 2 square, sir.
Okay. So first of all, what should you do in order to evaluate this integral? That is my question.
singular point கண்டுபிடிக்கணும் சார்.
Yes, we'll have to identify the singular points. Okay, how do we identify the singular points?
So denominator part should be 0.
So the singular points are given by z square plus 4 equals 0. So when you solve this, what are the points that you will get?
minus 2i
Only that one. Z
and
equals.
plus 2i.
Plus 2i.
So you will have plus or minus
Or
2i.
2i.
Okay, if you locate these points inside the loop or on the contour, where are these points lying? Where are these points?
Imaginary
East side also.
How many? Okay, out of these points, how many points are lying inside this? This is your point iota, and this radius, this radius is 2 units.
Sir, both is lying inside.
Sure.
And no, I mean minus 2i won't be lying. Plus 2i only, sir.
So this is your I, this is 2 units. Okay, the radius is 2 units. So in between you have 2i, and this point is your 3 iota, and this is 0, and actually this point. Okay, so this point is your iota, because from here to here only you have, this is minus iota. From here to here only you have 2 units. So out of these 2 points, the only singularity lies inside CS 2 iota. Okay, so your integral 1 upon z square plus 4 dz may be written as what? Tell me that. How may we write this one?
One by z minus 2i into z
Yeah.
plus 2i.
Come again, please.
1 by z minus 2i into z plus 2i.
Okay, good. So out of these things, how should we consider it? Is it now ready to apply your Cauchy integral formula? Guys, is it now ready to apply your Cauchy integral formula?
Yes, sir. Taking f of z to be 1 by z plus 2i, and denominator we have z minus 2i.
If you consider it in this way, you can very well apply your Cauchy integral formula. Okay, when you apply your Cauchy integral formula, what do you get? This quantity is equal to what?
2 pi I
2 pi I.
f of,
So here, what is your function?
1 by z plus 2i.
1 upon z plus 2i, and this has to be evaluated at the point z equals 2i. Okay, because that is the singularity that lies inside the given circle. So when you do it, you would get 1 upon 2 iota plus 2 iota. So it is 2 pi I upon 4 times of iota. It is pi upon 2. Simply pi upon 2. Iota and iota gets cancelled, and your 2 gets cancelled with 4. So you will be left with pi upon 2. Is that clear?
Yes, sir.
Yes,
So
sir.
what about the people on YouTube? Is it clear to you people as well? So monitor the responses. I'll note it down later. Okay. The same thing we'll have to do and see what happens for this. Even for this case. Okay. I think now these are not needed anymore. Here we are asked to evaluate this one over C, and this is integral over C 1 upon z square plus 4 whole square dz. Again, if you find out the singular points, only the point 2i lies inside and minus 2i lies outside. So 1 upon z plus 2i multiplied with z minus 2i whole square dz. We can split like this. After which, what should we do? Which theorem is to be used? Guys, you can't take this much time. Yes, you will have to make use of the extension theorem. Okay, how will you apply your extension? How will you apply your extension? What you said is right. Should we do some changes in the integrand? Okay, should we do some changes here? It's yes or no question. Should we do some changes here or not?
Sir, changes means what?
Like, do we split things up? Do we segregate things up? Or like, sometimes we may be in a situation to write things like this. These kind of changes I am asking.
So I think
What do you think? तुझे क्या लगता है? ऐसा लिखना चाहिए?
सर अगर एक ही फंक्शन हो तो लिखने का जरूरत नहीं सर, तो दो फंक्शन है z plus 2i z minus 2i, तो करना पड़ेगा शायद सर।
इनमें तो कितना सिंगुलरिटीज है? दोनों सिंगुलरिटी है?
नहीं सर, एक ही सिंगुलर है, z माइनस z इज इक्वल टू
ठीक है, अगर एक ही सिंगुलरिटी है तो हम कैसे करेंगे? ஒரே ஒரு சிங்குலாரிட்டி இருந்துச்சுன்னா நம்ம எந்த மாதிரி எழுதுவோம்? If we have only one singularity, how do we write?
2 pi I by 1 factorial वो है क्या सर?
Fine, that is a separate thing. Here, out of these two functions, you people say that we have only one singularity that is lying inside it. Okay, that is lying inside the given contour. In that case, how do we first write this one?
z plus 2i को
Numerator,
Okay, in the numerator,
we have 1 by z minus 2i the whole square.
good. Then,
The denominator we have z plus 2i the whole square.
okay, good. Now apply your Cauchy extension theorem. That is the extension of Cauchy's integral formula. So now what you have to do is that you will have to treat this entire numerator as a single function. Okay. So once you treat this as the single function, how do you write this thing using your Cauchy's extension? That is the extension of Cauchy's integral formula. How do we write?
2 pi I
Hmm.
by 1 factorial
Okay.
f prime of
Sorry.
f prime.
F prime, here we have not specified anything as f. So what does your f prime mean?
So we are differentiating f of z
Yeah, you will have to differentiate with respect to what?
with respect to singularity. 2
Sure. D upon what do we have here? That's my question.
dz.
dz, that's it. So we'll have to differentiate with respect to z. What function?
1 by z minus 2i the whole square.
Okay, z minus 2ib whole square. Good. So is it enough if we just simply differentiate, or should we do anything else too?
Evaluate the at the point
Derivative at the point z
2i.
equals 2i. Good. Okay. So you have this 2 pi I that is there. Okay, that's fine. And when you differentiate this quantity, what do you get? That is quite simple, I guess. So differentiate and tell me what do you get? You people are taking this much time to differentiate this one. Should I teach that too? That is the basic calculus. Guys, are you working it or not? There are 11 members here to give the answers, but I'm getting answers from very few people, only 2 or 3. What do you get? When you take t equals c minus 2i, what is your dt? Class, will you give answers for this or not?
dz.
Do the change of variable. Then your d upon dz of 1 upon z minus 2i whole square simply becomes d upon dt of 1 upon t square. So it is d upon dt of t to the power minus 2. Do the differentiation. What do you get?
Minus 2 by z minus 2i whole cube.
So here you are going to get minus 2 upon z minus 2i.
Z minus 2i the
cube.
whole cube.
Whole cube.
See guys, this is basic calculus that you have studied in 12th standard. There is nothing new. I don't know why you people are being so silent. Actually, you people are not ready to work. Okay, is it done or should we do anything extra?
Evaluate at the point.
And are you sure of the things that we are doing here? I think there is a mistake. Go through once again.
Z plus
Not in your
2i the whole cube.
Exactly. Here we must take this part in the numerator and this part in the denominator. Because this will give you 2i as your singularity. This will give you minus 2i. So here you'll have plus, here also you'll have plus. The same thing works for plus 2i because this is a constant. Okay, you will have to substitute this one. So when you substitute, what you are going to get is minus 2 upon 4i cube. So it is minus 4 pi I upon 4 cube, and I cube is simply minus I. So minus minus gets cancelled, I gets cancelled. We are going to have 4 upon 4 square, which is, sorry, pi upon 4 square, which is pi upon 16. Is that clear?
Yes, sir.
Sir.
Yes, sir.
The next question is, I think we have this page from here. Let C be the circle. Absolute of Z equals 3. What is the contour given to us?
Absolute of Z equal to 3.
So what is the center and what is the radius?
Center at 0 of radius.
Good. Go through the problem and you will have to explain what the problem is. Yes, anyone of you? What is given in the question?
Sir, here our contour is circle with radius 3, sir.
Okay.
and it is described in positive sense, sir.
So it is described in positive sense.
And they have given the function z of z
Okay.
with the condition that mod of z, absolute of z is not equal to 3. We have to show that g of 2 is equals to 8 by I.
Okay. So this is valid for interior of the circle. Okay. Only the points on the interior. For the points on the interior, we have defined g of z to be like this, not for the points on this. Right? So it is given. This is given. So with which what shall we do? So this is given and we are asked to find out what? So with this
Sir, value
what
of
should we find?
Value of z, sir.
Value of z
When absolute
Okay.
of z is greater than 3.
greater than 3.
So only that one. I think that is the second part of this question.
We need to
Sir,
show
must we-
that g of 2
G
is
of 2
equals
is
to 8
equal to
by
8 by
I, sir.
I.
Okay. So in the given one, what is the variable of integration?
Yes.
Yes. Okay. So here the z refers what? If we take this as equation 1, what is referred by this z?
point variable, sir.
Point or a variable?
Point, sir.
Point.
Okay. I agree to the fact that it is a point. So it is a point on the contour or inside the contour or outside the contour.
Sir, inside.
सोच के जवाब देना. Plus think and say. Z is a
Sir,
point
modulus
here.
Z when sir, absolute of Z is not equal to 3 जब
तो absolute of Z 3 के बराबर नहीं है तो क्या होगा?
वो on the line वो
So we lose the possibility that that point Z lies on the contour. Okay, good. So the point Z may be inside this contour or outside the contour. Where does it lie? Inside or outside? And for what type of points Cauchy's integral formula is spoken? If you know that, you can answer this.
सर लाई जब अंदर होगा तभी हम लोग फॉर्मूला अप्लाई कर सकते हैं क्या सर?
Yes. अगर तुम अंग्रेजी में बोल पाते तो सबको समझ में आ जाएगा.
If the point lies inside the counter, we can apply the Cauchy integral
Yes.
formula.
So if you have to apply your Cauchy integral formula, then this point must be inside the contour. Okay. So what does your Cauchy integral formula say? Tell me the formula. அந்த ஃபார்முலா என்னன்னு சொல்லுங்கன்னு சொல்றேன்.
F of Z naught is equal to
Yes.
1 by 2 pi I integral over C F of Z dz by Z minus Z naught.
Okay. If you have to redefine it, like இங்க நம்ம கொடுத்து if you have to write something of this form, what is the thing here? You change the variable of integration. You will have to rewrite your Cauchy's integral formula in the given format. How do you write? Yes, your answer is right, Yamini. I'm asking you people to just reformulate these things.
Sir, 2 pi I f of
2 அந்த பக்கம் கொண்டு போகணும் சார்.
Okay, so we can just bring this 2 pi I to this side. Okay, then there are few more changes. Look for the variable of integration.
Variable, yes, change.
Okay, so if you first of all you will have to change the variable of integration to s. Good. Then anything else?
So z
Any
naught
other
to
changes?
Z naught to Z, sir.
That's it. Okay, so with which can you identify your function f? What is the function here?
two x
2x
sy minus.
Okay, so comparing with equation 1, we get f of s is 2s square minus s minus 2. Is that clear? Guys, is that clear?
Yes, sir.
Okay.
Yes, sir.
You people told me that z is a particular point here. In that case, what is your g of z? Then g of z is what? This is my question. You just a mere comparison will give you all these things. You don't have to calculate anything. Just a comparison, and if you put f z, just do the comparison of Cauchy's integral formula, the reformulated Cauchy's integral formula with your equation 1.
2 pi I f of
g of z equals 4.
2 pi n.
2 pi I, someone was saying 2 pi I and Karan is saying 4. What is the answer? You will have to just compare this and this one.
2
So you
pi
just
I.
compare this and yes,
2 pi I f of
yes. 2 pi I multiplied with f of z. Okay. Now is it possible for you people to calculate g of 2? Plus, can you guys find out the value of g of 2 from this?
Yes, sir.
Okay. So from this, your g of 2 is nothing but 2 pi I multiplied with f of 2. And it is 2 pi I, and f of 2 is what? 2 times of 2 square minus 2 minus 2. So what do you get? 2 square is 4. When you multiply that with 2, you are going to get 8. 8 minus 2 minus 2. So the answer is
8 pi I.
8 pi I. Good. Now, the question is changed. What happens when absolute of z is bigger than 3? So in this case, you are going to have a contour of radius something. Let me call that as r, and this r value is bigger than 3. Right? And you are asked to find out the value of g of z when this is not the case. What can it be? Or as of now, just forget about that absolute of z not equals 3. You just forget about that one and just look for the value of g of z, and along with your Cauchy's integral formula, you will have to make use of Cauchy's-Gosar theorem. That is the hint I am giving you people. Guys, you have given me that this is your value of g of z. When is this possible? Plus, am I audible, first of all?
It lies inside, sir.
Okay, when your z lies inside the contour, you will have this to be the case, right? So, when absolute of z is bigger than 3, when your absolute of z is bigger than 3, what is the region to you? Outside this region only we are considering. Am I right?
Yes, sir.
Yes, sir.
0,
Good.
sir.
So your g of z is going to be 0. In one case, it is going to be 0. That's good. In the other case, so when is it 0, first of all?
Lies around
If you,
outside the circle.
so this is 0 when z lies inside or outside?
Outside.
Sure. Now the considered region is outside the circle. Exterior of the circle is the region that we have considered.
Sir, inside is 0, sir. क्योंकि contour outside of the circle है, sir.
So contour to circle ही है यहाँ. When z lies inside, okay, when your z lies inside your this function, you have this function, right? This function is analytic in the given region. Am I right? Class, am I right or not? If the given region is exterior of the circle and your z lies inside the circle, you do not have any singularity of this function in this region. Am I right or not? புரிஞ்சுதா இல்லையா? ஏதாவது வாயத்துடன் சொல்லு.
Sir, one more time explain करो sir वो inside.
You have this circle and both the circles are same, right? I am telling that here I am considering the inside of the circle and there I am considering the exterior of the circle. And if my point z lies inside this, then this function does not have any singularity in this region. This is what I am trying to say. Am I right or not?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
If you don't understand what I say, you ask for the repetition. I'll repeat it. Don't be ideal. So, this function is analytic everywhere on this region. Am I right?
Yes, sir.
Yes, sir.
What does your Cauchy-Gosar theorem says? What does your Cauchy-Gosar theorem tells you?
Sir, if a function is analytic at all points, then
All points of what?
on a simple closed
On a
interior,
simple?
sir. Closed contour.
So we need only simple closed contour, or we need a domain, a region, or something like that.
Region.
A region. Okay. What if it is a multiply connected region? We have seen some extension to Gauss theorem as well, I suppose. Am I right?
Yes, sir.
So extension of Cauchy-Gauss theorem to multiply connected regions. It is a multiply connected region. So in this case also, if your function is analytic in the given connected domain, then the integral of this over that particular region, okay, you take it R or anything, then you will get 0. Right? So when Z lies inside absolute of Z less than or equals 3. So in this case only it is going to happen. When the Z lies in this particular region, what happens? Do we have any theorem or any result to study about the analyticity or the value of the interval for such case? When your Z lies in this, we have a result. We made use of that one, right? When Z lies outside this one, that is in this region, if your Z lies, what happens? Do we have any result? Do we have any result? It is just a yes or no question. Yes, do we have any result? I think concerning to complex intervals, you people have not studied much of results. You people have just studied Cauchy-Gauss Cauchy interval formula, and recently we studied Liouville's theorem. That's it. Only these things you people studied concerning to complex intervals. Among these things, do we have any results by which you can talk about the integral of this form when the Z lies in this region? It's a yes or no. ஆமா இல்ல படிச்சிருக்கோம் படிக்கல இவ்வளவுதான் சொல்ல போறீங்க, இதுக்கு இவ்வளவு யோசிக்கணுமா? क्या कनिष्क?
Yes,
हमें
sir.
पढ़ाया या नहीं?
सर वही देख रहा हूँ सर। नोट में
देखने की जरूरत नहीं है, सोचने की जरूरत है।
ठीक।
एक साल हो गया, बस देखते ही चलता है सब, कब सोचोगे? Guys, as of now we have not studied any results. Okay, when the singularity comes in, okay, so in this case when your Z lies somewhere here, this means this function has a singularity in that particular region. That region cannot be treated as interior of a contour. So if you have a singularity and it is defined on some interior of a contour, then you have the Cauchy integral formula to deal with such type of intervals. When it is of not that form, you do not have any result as of now. Okay. Till now we have not studied any results to deal such type of intervals. Okay. when you have to deal such type of integrals, you will have to study about the nature of the singularity that comes in. Okay, that and all we'll study in the upcoming lectures only. So once you know the type of the singularity that you have, then only you can talk about these type of integrals. Okay, but to apply Cauchy integral formula, that is not needed. Which type of singularity it is, that is not needed. If you have a contour inside which a function is defined, and if you have some singularity inside which you can do the things. In this case, you don't have to worry about the singularity type that you have, right? So I think the same set of people I want for the next problem solving as well. Okay, you people haven't prepared enough. Okay, I heard only few voices during this class. So I want the same set of people for the next class as well. Now I request everyone to join to Google Meet.